welcome to another section of multivibrators. And today we are going to discuss about astable multivibrator. We already know that timer IC NE555 can be used in monostable mode for producing a precision timer for a fixed time duration. But we can also use it in an astable mode to build a very stable 555 oscillator circuit which can generate highly accurate waveforms, and the output frequency can be adjusted using an externally attached RC tank circuit consisting of two resistors and a capacitor. This type of oscillator is mostly used for producing stabilized square wave output waveforms for a fixed frequency up to 500 kHz for varying duty cycles from 50 to 100%. In our previous sessions, we learned 555 timer as a monostable circuit which produces a single output one-shot pulse when triggered on pin 2. The circuit stops after a preset time and waits for the next trigger pulse to start over again. But to get the 555 oscillator to operate as an astable multivibrator, it is very important to trigger the IC continuously after every timing cycle. Now let's talk about theory. An astable multivibrator is also known as free-running multivibrator. It has no stable states, continuously shifts between two states without the application of an external trigger. The IC555 can be assigned to work as an astable multivibrator with the addition of three external components. Those are two resistors RA and RB and a capacitor, that is C. The schematic of the IC555 as an astable multivibrator along with the external components is displayed. Now we will look into the circuit diagram and its operation. We can see that the pin 2 and the pin 6 are connected, so there is no need for an external trigger pulse. It will self-trigger and behave as a free-running multivibrator. The pin 8 is connected to supply voltage, that is VCC, and we know that pin 3 is the output. The external reset pin is pin 4. A low pulse on this pin will reset the timer when it is not in use, generally attached to VCC. The control voltage is connected at the pin 5 to change the threshold voltage level. Pin 1 is the ground terminal. The timing circuit determines the width of the output pulse. It is calculated by the values of RA, RB and C. To understand the working principle of this circuit, we have to clarify it through the block diagram. The capacitor C charges towards VCC through the external resistors RA and RB. We can see that the capacitor voltage rises until it goes above 2/3 of VCC. It is the threshold voltage at pin 6 that drives the first comparator to trigger the flip-flop and the output becomes low. The discharge transistor is driven on and it discharges the capacitor through the resistor RB. The voltage of the capacitor starts to decrease until it drops below trigger level, that is 1/3 of VCC. At this time, the flip-flop is triggered so that the output goes high and turns the discharge transistor off. After this, the capacitor will again start charging through the resistors and the cycle will repeat. Now the derivation of time, frequency and duty cycle equations are as follows. The voltage across the capacitor at any instant during charging period is given as Vc is equal to Vcc multiplied by 1 minus e to the power t by Rc. The time taken by the capacitor to charge from 0 to 1/3 of Vcc is 1/3 of Vcc, that is equals to Vcc multiplied by 1 minus e to the power t by Rc. The time taken by the capacitor to charge from 0 to 2/3 of Vcc, that is T2, that is equals to Rc log of 3 base of E is equal to 1.0986 Rc. So the time taken by the capacitor to charge from 1/3 Vcc to 2/3 Vcc is Tc is equal to T2 minus T1, that is equal to 1.0986 minus 0.405 whole multiplied by RC, that is equal to 0.693 RC. Now substituting R, that is equals to RA plus RV in above equation, we have T high is equal to TC, that is equal to 0.693 multiplied by RA plus RV, where RA and RB are in ohms and C is calculated in farads. The time during which the capacitor discharges from 2/3 of VCC to 1/3 of VCC is equal to the time the output is low and is given as TD, that is T low is equal to 0.693 RB multiplied by C, where RB is in ohms and C is in farads. The overall period of oscillations, that is T, is equal to T high plus T low is equal to 0.693 RA plus 2 RB whole multiplied by C. The frequency of oscillations being the reciprocal of overall period of oscillation T is given as F is equal to 1 by T, that is equal to 1.44 by RA plus 2 RB whole multiplied by C. The equation indicates the frequency oscillation that is independent on the collection supply voltage VCC. The duty cycle is the ratio of time Tc during high output to the total time period T is given as D is equal to Tc by T multiplied by 100, that is equal to RA plus RB by RA plus 2RB multiplied by 100, where D is the percentage of duty cycle. Now we will talk about the applications of astable multivibrator. This oscillation circuit has several applications in the field of electronics. We will discuss some of these. The first one is square wave generation. The duty cycle of an astable multivibrator is constantly greater than 50%. A square wave is received as the output of an astable multivibrator while the duty cycle is 50% exactly. Duty cycle of 50% or anything less than that is not desirable with the IC555 as an astable multivibrator. Now let's come to the pulse position modulator. In this modulation, the position of the pulse transforms according to the modulating signal while the amplitude and the width of the pulse are fixed. The position of each pulse varies according to the instantaneous samples voltage of the modulating signal. To achieve pulse position modulation, two 555 timer ICs are used in which one works in astable mode and the other in monostable mode. Now the last application is frequency modulation. It can be used to generate frequency modulated signals. A modulating signal is given to the pin 5. The circuit of frequency modulation using an astable mode of operation of the IC555 is displayed. And with this, we have come to an end of this session, and today we have learned introduction to astable multivibrator, circuit diagram and operation of an astable multivibrator using 555 timer, working principle of the circuit diagram, derivations of time, frequency and duty cycle equations, and the applications of astable multivibrator. We will meet again with another interesting topic of this session. Till then, keep watching and keep learning.